there is something wrong with the way Apophis moves. A solid rock left alone in space settles into a clean, steady spin. Apophis does not. It tumbles and wobbles on two different clocks at once, the way a badly thrown football never finds its spiral. And in 2014, Peter Pravec and his team proved it. That wobble is a clue to what it is really made of. And on the 13th of April 2029, this tumbling world will pass closer to Earth than anything of its size in modern history. This is the story of Apophis and what our own planet's gravity is about to do to it. For a few weeks in the winter of 2004, a single point of light in the sky was the most dangerous object humanity had ever tracked. Astronomers had found it in June of that year from a mountaintop observatory in Arizona, and at first it was just another faint smudge crawling across the star fields. Then they ran the numbers forward, and the numbers said that on a Friday in the spring of 2029, this rock had something like a 1 in 37 chance of hitting the Earth. They named it Apophis, after the serpent the ancient Egyptians believed waited in the dark to swallow the sun. On the scale astronomers used to rank the threat of an incoming asteroid, a scale that runs from 0 to 10, Apophis was given a level 4. Nothing before it had ever been rated that high. Nothing since has been either. For a little while, the god of chaos held the record for the most dangerous object in the sky, and the people who study these things went very quiet and started checking each other's math. We are, of course, still here. The impact did not happen, and it is not going to happen. But the story most people carry about Apophis, that it was a doomsday rock, and then it wasn't, and so there is nothing left to worry about, is wrong in a way that is far more interesting than the scare ever was. Because Apophis is coming back. On the 13th of April 2029, it will pass closer to the Earth than any object of its size in recorded history. And there is a problem with it, not a problem that ends the world, a problem that means we do not actually know what is going to happen when it gets here. The way we called off the end of the world was with radar. In March of 2021, as Apophis made a distant pass, NASA aimed the giant dish of the Goldstone Deep Space Communications Complex in California at it, and paired that with the Green Bank telescope in West Virginia. They fired radio waves across millions of kilometers of empty space, caught the faint echo as it bounced back off the asteroid, and from that echo they measured its position and its motion with a precision that had simply not been possible before. The refined orbit closed the case. Marina Brozovic and her colleagues at NASA's Jet Propulsion Laboratory, working with the orbit specialists at the agency's Center for Near-Earth Object Studies, were able to rule out an impact, not just for 2029, but for at least the next 100 years. That included the thing they had quietly been most afraid of, the keyholes. A keyhole is a tiny region of space, only a few hundred meters wide, that acts like a trapdoor. If Apophis had passed through exactly the wrong one in 2029, Earth's gravity would have bent its path just enough to line it up for a real strike years later, in 2036 or 2068. The radar showed it will miss every one of them. So the fear was answered. The serpent will not swallow anything. And here is where almost everyone stopped paying attention. The moment the headline changed from "Asteroid might hit Earth" to "Asteroid will safely miss." But the scientists did not stop looking, because ruling out the impact only settled one question. It said nothing about what Apophis actually is, and what it is turns out to be the strange part. Think about what we assumed for all those years. We assumed Apophis was a rock, a solid, single, dependable chunk of stone, tumbling through space like a thrown stone tumbles through air. Something you could predict, something that behaves. That assumption sat underneath every calculation, and almost nobody questioned it, because for working out whether it would hit us, it did not much matter what the asteroid was made of. It only mattered where it was going. But the closer we looked, the less that picture held together. Apophis is not a tidy sphere. Radar and careful measurements of its brightness reveal a body that is stretched and lumpy, elongated, narrow, with a pinch in the middle. The best description astronomers reach for is a peanut, or a dumbbell, two rounded masses joined by a thinner waist, and a body shaped like that, doing what Apophis is doing, raises a question that the impact calculations never had to answer. Because Apophis does not spin the way a solid rock should, and once you understand why that matters, the flyby stops being a fun sky-watching event and becomes something closer to an experiment, one where we are not entirely sure of the result. Here is a thing that is true of almost every solid object left alone in space. Over time, it settles into a clean, simple spin, turning steadily around a single axis, like a well-thrown football holding its spiral. Physics pushes it toward that state, because that is the lowest energy way for a rotating body to exist. Give a rock enough time, and it will find its spiral. Apophis has not found its spiral. In 2014, Petr Pravec and his colleagues at the Ondřejov Observatory in the Czech Republic published a study in the journal Icarus, based on the tiny rhythmic changes in the asteroid's brightness as it turns. What they found is that Apophis is not spinning cleanly at all. It is tumbling. Astronomers call it non-principal axis rotation, which is a careful way of saying the thing is rolling and wobbling at the same time, like a badly thrown American football that never quite settles, wobbling end over end as it flies. And it does this on two different clocks at once. It rolls with a period of about 27 hours, and it slowly wobbles, precesses, over a much longer cycle of roughly 264 hours, around 11 days. So if you were floating beside it, the sun would not rise and set on any schedule you could hold in your head. The horizon would tilt and drift and double back. The same face would swing toward you, then away, then back at a different angle, and it would take you 11 days to see the pattern even begin to repeat. That tumbling is the first clue that Apophis is not the simple stone we assumed. Something about how it is shaped, or how it is put together on the inside, left it rolling instead of spinning. And the leading explanation for that is the part that should make you lean in. The reason a body ends up shaped like a peanut is often that it is not one body at all, it is two. Astronomers call these contact binaries, two separate rocks that drifted together in the slow, gentle gravity of deep space, touched and stayed touching, joined at that narrow neck by nothing more than their own faint pull on each other, and whatever weak friction exists where they meet. They are not welded, they are not fused. They are resting against one another, and the join is the weakest part of the whole structure. We do not know for certain that Apophis is a contact binary, but its shape strongly suggests it, and its tumbling fits. And there is a second layer to this, which is what the inside is probably made of. Most asteroids this size are not solid rock at all. They are what scientists call rubble piles, loose heaps of boulders, gravel, and dust, held together by their own weak gravity, with empty space threaded all through them. Not a stone, or a flying pile of debris that has agreed, for now, to travel together. We have seen this up close before, and that is why we believe it. When spacecraft visited the asteroids Itokawa and Bennu, they did not find solid stone. They found exactly this, piles of loose material, so weakly bound that in one case the surface behaved almost like a fluid when it was disturbed. Bennu was so loosely packed that a probe pushing into it met almost no resistance, sinking as if into a pit of gravel. There is no strong reason to think Apophis is any different, and every reason from its shape and its wobble to think it is the same kind of thing, a body with the strength of a sand pile, wearing the shape of a stone. So assemble the real picture. Apophis is very likely a loose heap of rubble, possibly in two lumps joined at a fragile neck, tumbling instead of spinning, held together by almost nothing. That is the object that is going to pass closer to us than our own satellites. And this is where the problem in the title finally shows itself. Because when something that loosely bound comes that close to a planet, the planet does not just let it go by. The planet reaches out and touches it. On the 13th of April, 2029, Apophis will pass roughly 31,600 kilometers above the surface of the Earth. In miles, that is a little under 20,000. To feel how close that is, remember where our own machines live. The satellites that carry our television and our weather data sit in a ring about 36,000 kilometers up. Apophis will pass inside that ring. A natural object the size of 3 or 4 city blocks, older than the Earth itself, will slide in between us and our own spacecraft. And at that distance, gravity is not a gentle thing. Gravity gets stronger the closer you are, which means Earth will pull harder on the near side of Apophis than on the far side. That difference, the near side yanked more than the far side, is a stretching force. Astronomers call it a tidal force, and it is the same effect that raises the ocean tides on Earth, only here it is being applied to a loose pile of rubble that is barely holding itself together in the first place. The scientists have modelled what this does, and the results are specific. In 2023, a team led by Yaeji Kim, working with Olivia de Martini and Ronald Louis Balouz, published a study in the monthly notices of the Royal Astronomical Society, modelling what they called tidal resurfacing. As Earth's gravity stretches and shears the asteroid during the roughly 6 hours around closest approach, loose grains and small blocks on its surface will be shaken free and moved. Their models predict this will begin about half an hour before the closest point, and rework something on the order of 1% of the entire surface. A follow-up study titled Shaking and Tumbling in the Planetary Science Journal went further, predicting landslides as slopes give way, faint quakes rippling through the body as it settles, and a measurable change in the way Apophis spins after the encounter is over. Read that again, slowly. We are predicting earthquakes on an asteroid, landslides on a world smaller than a mountain, and a change in its spin that we will be able to measure. Earth's gravity is going to reach out and physically rearrange another body in space, and we are going to watch it happen in near real time. That has never been possible before. Picture standing on Apophis in the final hour. You would need to imagine it, because no human will be there. But the physics is real, and it is worth living inside for a moment. The ground beneath your feet is not stone. It is a rubble field, loose rock and grit, and the gravity is so faint that a careless push would launch you off the surface entirely, tumbling into the dark. Overhead, the sky does not hold still, because the whole world you are standing on is rolling and wobbling, and the stars wheel in a slow, sickening drift that never quite repeats. And then the Earth comes up. Not a distant point of light, an enormous blue and white face swelling until it fills a quarter of the sky, close enough that you could pick out the shapes of continents and the glow of cities on the night side. It rises, and it keeps rising, larger than anything that has ever hung over this piece of rock in its billions of years of existence. And you feel the ground begin to move, not violently, gently, but wrongly. The pebbles around your boots start to shift, to creep, to slide, as if the surface itself has become uncertain about which way is down. A slope in the distance lets go, and a slow avalanche of rubble drifts downhill in eerie, floating silence, because there is no air to carry a sound. The neck of the peanut, The weak join at the waist of the world. Groans under a pull it has not felt in 100 million years. Nothing screams, nothing shatters, but everything is moving, and for those few hours, the little world is not solid ground at all. It is a thing being handled. The most unsettling number in all of this is the timing. About 30 minutes before closest approach, while the encounter is still building, before Apophis even reaches the nearest point, the models say the surface begins to move. The stretching has already grown strong enough to start shaking things loose. The asteroid begins to change before the moment we would think of as the event. And here is the honest edge of the story, the thing the scientists will tell you if you ask. We do not know exactly what will happen. We do not know how strong Apophis is on the inside. We do not know for certain whether it is one body or two. We do not know precisely how much its spin will change, or where the landslides will fall, or whether that fragile neck will simply shed some rubble, or do something more dramatic. The published models predict resurfacing and quakes and a spin shift, not a breakup, and not fragments thrown toward Earth. The flyby distance is far too great, and Apophis far too cohesive for the planet to tear it apart. But the deeper truth is that we are watching to find out. This is not a prediction we are confident in. It is a question we are finally close enough to answer. There is a version of this story circulating that says Apophis is secretly flexing, coming apart from within, and that Earth will finish the job and rain pieces down on us. That is not what the data says. Impact has been ruled out for at least a century. What is true is stranger and more honest than the doomsday version. We are about to run a physics experiment on a live asteroid at a scale no laboratory could ever build, and we genuinely do not know the full result. That uncertainty is not a reason to be afraid. It is the reason we are going. Because we are not just going to watch from Earth. There is already a spacecraft on its way to meet Apophis in person. It used to be called OSIRIS-REx, the mission that flew to the asteroid Bennu, scooped up a sample of ancient rock, and dropped it back to Earth in the desert in 2023. The spacecraft that delivered that sample did not come home. It kept flying under a new name, OSIRIS-APEX, and its entire remaining purpose is Apophis. It will not arrive in time to see the flyby from up close. Instead, it will catch up about 2 months later, in June of 2029, and then it will do the thing that turns this whole spectacle into science. It will settle in beside Apophis and spend roughly 18 months mapping it, its shape, its surface, what it is made of, how fast it is spinning. It carries no seismometer, so it cannot feel the quakes directly, but it can read the evidence of them. Fresh patches of surface exposed where old dust slid away. Boulders that have moved between one photograph and the next. The faint scars of landslides that were not there before. It will document, boulder by boulder, exactly how the encounter with Earth changed a small world. That is the payoff. Everything the flyby does to Apophis, the resurfacing, the quakes, the shift in its spin, would be a guess we could never confirm if there were no one there to measure it afterward. OSIRIS-APEX is the reason 2029 becomes an experiment instead of just a light in the sky. It closes the loop. It turns "we think this is what happens when a planet handles a rubble pile" into "here is what happened, in detail, forever." By coincidence, the day of the closest approach is a Friday the 13th. It is hard to imagine a date the god of chaos would have chosen more carefully for itself. And on that night, across Europe, Africa, and Western Asia, people will be able to walk outside and look up and see it. Not through a telescope, but with the naked eye. A moving point of light, drifting steadily across the constellations, faster than any star. A piece of the early solar system passing between us and our own machines. Something close to the whole population of the planet will be in a position, in principle, to watch it go by. Most of them will see a light. What they will actually be looking at is a fragile, tumbling heap of rubble, possibly two rocks resting against each other, at a neck that has held for 100 million years, being stretched and shaken and quietly rearranged by the gravity of the world they are standing on. They will be watching a planet touch an asteroid. We thought Apophis was the rock that would kill us. Then we decided it was nothing to think about at all. It is neither. It is a small, loosely bound world, coming closer than anything of its kind ever has, carrying an interior we cannot yet see and a strength we cannot yet measure. And for a few hours in the spring of 2029, the Earth is going to reach out across 31,000 kilometers of empty space and lay its hands on it, and we are finally going to find out what it is made of. The serpent is not coming to swallow the sun. It is coming close enough for us to learn what it is. And that, in the end, is the more astonishing thing. Thanks for watching, and I'll see you in the next one.